Use first principles to find the derivative of each of the following functions. Okay, we've done this before. Limit as h goes to 0, f of x plus h minus f of x all over h. And they never do mention what x is, so these are going to be general to the very end, which is fine. So f of x we have, f of x plus h we get by plugging into this function. I'm going to try to do that on the fly to save a little bit of time. F of x plus h is 4 x plus h squared, x squared plus 2xh plus h squared minus 7. All that is f of x plus h minus, and then we have f of x, which is 4x squared minus 7. All that is over h. So, limit as h goes to 0. Can we cancel anything? I have 4x squared here minus 4x squared there. I think it's safe to chop both of those. Here we have minus 7 and minus 7. Those will cancel. So the pieces that survive are going to be 8xh plus 4h squared all over h. If you actually divide the top and bottom by h, you get 8x plus 4h, limit as h goes to 0. And if h goes to 0, that means our derivative is simply 8x. So you can either say f prime of x equals 8x, or dy dx equals 8x. That means put in an x value once you find one and multiply it by 8, and that will tell you the slope of this curve. For b, I'm going to need all this room, so if you need to see question A, back up. For b, our original function is 2x cubed minus 6x. Our f of x plus h is going to be 2x plus h cubed minus 6x plus h. Now, the binomial theorem or Pascal's triangle tells us that when you multiply this out, you get x cubed plus 3x squared h plus 3xh squared plus h cubed. And then we have minus 6x minus 6h. If you want to multiply this out brute force, you'll see that this is true. I'm shortcutting because I think you've seen this before by now. 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 6x minus 6h. I don't think anything cancels there. Nope, not a thing. So, our derivative is the limit as h goes to 0 of f of x plus h, so all this stuff, 2x cubed plus etc. minus f of x, which is 2x cubed minus 6x all over h. So that's limit as h goes to 0. We have 2x cubed, and here minus 2x cubed. We have minus 6x, and here plus 6x, so those drop out. And that leaves us with 6x squared h plus 6xh squared plus 2h cubed minus 6h all over h. If we divide the whole works by h, we get limit as h goes to 0, 6x squared plus 6xh plus, running out of space, 2h squared minus 6. And now, if h goes to 0, all the terms with h in them vanish, and we find that our derivative is simply 6x squared minus 6.